Okay, today we're going to do something called solving systems of equations. By substitution. You will need to take notes in your notebook today to write all this down. Now, think about what it means to substitute. Usually, if I give you something like y equals negative 3x plus 11, and then I tell you that x is equal to 8, so we want to figure out the value of y, think about what you would do. You would just take the 8 and you would substitute it in place of x. So this would be y equals negative 3 times 8 plus 11. We would do the work. Negative 24 plus 11 is negative 13 for y. Now, it's not just x that we could be given. Again, if I gave you the equation 2x plus y equals 24, and then I said y is equal to 5, and we want to know x. Well, it doesn't change the way we think about things. We would take the 5 and we would put it in place of y. So it would look like 2x plus 5 equals 24. And then we would use the Great Wall if we need to, but we would solve. So 2x is 19, divide by 2. Even though x ends up being a fraction, it doesn't change the way that we actually approached it. It's all based on the idea that substitution means replace. What's new is now we're going to look at not just replacing a regular number. So if I gave you something like negative 4y plus x equals 17, and then I told you that x equals 9y plus 2. Notice that y is not something just, x is not something just as simple as the number 8. It's actually an expression. That doesn't change the way that we can think about it, though. We can take all of this stuff for x, and we can substitute it in place for x in the other equation. I'm going to take everything for x and substitute it for x in the other equation. So the way that would look now is it would be negative 4y plus, instead of x, I'll write 9y plus 2 equals 17. I continue with my idea of substituting. Now we can just solve for this equation, and if I combine like terms, I get 5y plus 2 equals 17. Subtract 2, get 5y is 15. Divide by 5 so that y is 3. Now if I really wanted to, I could substitute this back into here so I could figure out the value of x. So I was given x equals 9y plus 2, but now I know y is 3. So x equals 9 times 3 plus 2, or 27 plus 2, which means that x is 29. This is something called the substitution method. All it means is that we have one variable alone so that we can substitute into the other equation. So, if I were to give you a system of equations where one equation is x plus 2y equals 17, and another equation is x equals y plus 8, I recognize that x is all alone in the second equation, so I'm going to take everything here and I'm going to put it in place or substitute for x. So if I do that, this will be y plus 8 plus 2y equals 17. It is important to notice that the only variable I see now is y. So I can combine like terms and get 3y plus 8 equals 17. Subtract 8 from both sides and get that 3y equals 9. divide by 3, and get that y equals 3. Now, because I'm solving a system, remember I need both x and y, so I'll take this y value now, and I'll plug it into one of the equations. It really doesn't matter which one. This one seems easier though. I had x equals y plus 8, but now I know that y is 3. So x equals 3 plus 8, which means that it equals 11. Do notice how in this equation, or in this system of equations, the x was alone in one of the equations. It doesn't always have to be x. I could give you the system of equations that says y equals 4x plus 1 and y plus x equals 11. Now, I notice that y is alone in the first equation. So notice that what I'm doing is just looking at the problem and seeing what there is to see. Since I see y alone, I'm going to take all of this and put it in place of y in the other equation. Okay, so I'm going to take this and put it right there. And now when I write that out, I should have 4x plus 1 instead of the y plus x equals 11. That was just the rest of the equation. Again, notice that now the only variable I see is x, so I combine like terms and solve for x. I get 5x plus 1 equals 11, subtract 1 and get 5x equals 10, divide by 5 so that x equals 2. So that is the x coordinate of my solution. Next I need y, so I take this x and I plug it into either one of these equations so that I can figure out y now. It looks like the first equation would be easier because it says y is equal to 4x plus 1, but now I know that x is 2. So y is equal to 9. So that is my solution. X equals 2, y equals 9. And I should have written it like this in the ones above as well. Remember, the point of intersection is the solution. Okay? So the only other thing about this that we need to be careful about is what happens when you're not given a variable by itself already. So if I gave you y plus x equals 6, and then x minus 2y equals negative 6, the first thing that we have to do is look at the problem and notice that no variables are completely alone. Well, what that means is we have to make a choice. It looks to me like it might be rather easy to get y alone in the first equation, but there are other options. That's just what it seems like to me that's easy. Because if I think about y plus x equals 6, to get y alone, the only thing I have to do is subtract x from both sides. That would give me y equals 6 minus x. Now that I notice that y is alone, recognizing I did that from the first equation, now I can take all of this stuff for y and I can put it in place of y in the other equation. So I'm going to take 6 minus x and I'm going to put it in place of y here. Notice that there's a 2 in front of the y. So this is going to be x minus 2. And since I have that 2 there, I need parentheses. So I'm going to have 2 times 6 minus x, and then the equals negative 6 for the rest of the equation. This, notice, is going to be distribution, and I'll pay careful attention to this negative right here. So I'm going to distribute that negative 2 and get x minus 12 plus 2x equals negative 6. So the only thing that's different about this problem than the one above was that I actually had to get y alone in this equation. But remember, I could have chosen to get x alone, or I could have chosen to get x alone in this equation. Okay, so we finish solving. We get 3x minus 12 equals negative 6. Add 12 to both sides. Get 3x equals 6. Divide by 3. Get that x equals 2. Well, now that I have x equals 2, I take this, sub it back into x there. Okay, so all I have to do is y equals 6 minus x, but now I know that x is 2, so y equals 4. I have my x, I have my y, so my solution is the point 2, 4. That, if I graph these equations, that would be the point of intersection. Okay? That's the basic idea of substitution. We will practice this a lot more in class. In the meantime, if you could come into class, please, with these two questions, I'd like you to try them. The first one is y equals 11x minus 40, and y minus 7x equals 4. Solve that system of equations using the substitution method. The other one, if you could please try x equals negative 3y plus 11, and 3x minus y equals 3. Okay? I will even tell you the solution to this one is the point 11, 81, and the solution to this one is the point 2, 3. I'd like to see you do the substitution method and show all the work, making sure that you get these answers. If you do not, definitely be prepared to ask questions. I will see you on Monday. Have a good weekend.